Good evening, everyone. Crack Economics and Statistics welcome you all on this today's YouTube live workshop on all t-tests and regression analysis using SPSS. This is the second session. In first session, uh, you learned about the idea of regression analysis, the logic behind the regression analysis, how to perform the simple linear regression in SPSS, and the interpretation of it. So today we are going to discuss the types of t-tests, the use of this t-test, when to use these different t-tests that we have, and how to perform all the three t-tests in SPSS and their interpretation as well. Since you know that this is a live session, you can ask the question in the chat box. I will try to answer as many questions as possible. Uh, I also request you all to subscribe to my YouTube channel, Crack Economics and Statistics, so we can organize such kind of workshops in near future for the betterment of the students and research scholars. So in the first session, as I said, we discussed the regression analysis, meaning, logic, theory, and practice. And today we are going to discuss all t-tests, the theory of t-tests and the practice using SPSS. So basically, t-tests are used to compare one or two means. So when we are talking about the t-test, we are interested in comparing one or two means. So basically, t-tests are used to compare the means. There are three types of t-tests. First is one sample t-test. Second is paired t-test, and third is independent t-test. So in this session, I'm going to discuss the theory and practice of all these three t-tests. So first we are going to discuss the theory of each test, and then I'll show you how to perform this test in SPSS and how to interpret the result of the test. There are many students, there are many participants of this workshop. People are joining across the world. People are joining from Africa, Thailand, Malaysia. So thank you very much for joining this session. And as I said, this is a live session. You can ask the questions in the comment. We will try to answer your queries. So let's begin with the assumptions. All t-tests have the same assumptions. First is the sample size should be small. Now, if you refer to the literature, the sample, if your sample size is more than 30, we say that it's a large sample. But there is no magic number that we can say this sample size is small or this sample size is large. So if all assumptions are met, you can use the t-test to compare the means, even if your sample size is large, more than 30. So in general, the t-tests are used when the sample size is small. Second, sample should be collected randomly. When we collect the sample from the population, we collect it randomly, which means that each and every observation has an equal probability of being selected in the sample. So if the sample is not randomly collected, we cannot perform the t-test to compare the means. So the random selection of the sample is very important to perform these tests. Third assumption is selection of observations should be independent. So the selection of one observation does not affect the probability of other observations of being selected. Suppose we have three observations, X, Y, and Z. So if I select observation X, that does not affect the probability of observation Y and Z being selected in my sample, which means that the observations in this sample X, Y, and Z are independent. Fourth, population variance should be unknown. Here, the variance of the population is unknown. So we do not know the variance of the population, and therefore we are going to use this sample standard deviation or sample variance. We are not going to use the population variance when we perform the t-test. Fifth, variable must be measured on interval or ratio scale. This means that we should have quantitative variable or continuous variable. If we have nominal or ordinal variable, we cannot use t-test. Now, if you want to learn the difference between nominal and ordinal variable, you can check the video on our YouTube channel. So here we must have the quantitative data. So for example, if we have IQ level, then we have the data on IQ. If we have the marks, so that is quantitative data, income, expenditure, advertisement expenditure, sales of a company. So these are quantitative data. So we cannot perform the t-test if our data is nominal or ordinal. Now, what are the steps involved in in all t-tests? So first step is to define the null and alternative hypothesis. Now, how to frame the null and alternative hypothesis? What do we mean by null hypothesis? What is alternative hypothesis? You can again go to our YouTube channel and find the video on null versus alternative hypothesis. Second step is to define, to specify the level of significance, which is denoted by alpha, and this is also known as type 1 error, right? So we specify the level of significance. That is the second step. You can also find the videos on alpha, level of significance, p-value, the relationship between alpha and p-value on our YouTube channel. Third test, perform the test in SPSS. And fourth, interpretation of the result according to the decision rule. Now, what is the decision rule? When we calculate the test manually, we always compare calculated value with the tabulated value. But when we use any software, that software generates p-value. So we compare the p-value with our level of significance, that is alpha. And this alpha is specified before we perform the test. So the decision rule is, if p-value is less than alpha, we reject the null hypothesis. If p-value is less than alpha, we reject the null hypothesis. So null hypothesis is rejected if the p-value that generates by the software is less than the level of significance. Then we are going to reject the null hypothesis. And if p-value is greater than alpha, we fail to reject the null hypothesis. So the decision rule is very important because we interpret the result, and that result based on the decision rule, that interpretation based on the rejection or non-rejection of the null hypothesis. So this decision rule is very important. Now, what is one sample t-test? There are three types of tests. There are three types of t-tests. So now we are going to discuss the first type of t-test, which is one sample t-test. It is a parametric test. So first, parametric test means normality assumption is required to perform this test. If our data is not normally distributed, then this test cannot be used. So one sample t-test is used to perform or to compare the observed mean with a given population mean. So here population mean is given. So we compare the observed mean, that is sample mean, with given population mean. Let's understand this with the help of example. We could use this test whether we collect the sample from the population having a monthly income of $7,000. So to test this, we need to collect the sample and compare the sample mean with given population mean. So what is population mean here? It is $7,000, $7,000, which is given. So we first collect the sample, we calculate the sample mean, and then we compare the sample mean, the observed mean, with a given population mean or given value. So what is the null hypothesis in this case? The null hypothesis is there is no significant difference between the observed mean and the population mean. There is no significant difference. Or the observed and population means are equal. This is how we can frame the null hypothesis in case of one sample t-test. First, there is no significant difference between the observed mean and the population mean, or we can say the observed and population mean are equal. Now, what is alternative hypothesis? The alternative hypothesis is there is a significant difference between the observed and the population mean, or we can write that is the observed mean is significantly different from the population mean, or the observed and population means are not equal. Manually, we can calculate the t statistic for one sample t test by using this formula. Here x bar is sample mean, mu is given population mean, S is sample standard deviation, and N is sample size. So again, T calculated is x bar minus mu upon S upon under root N. Here, x bar is the sample mean, mu is the population mean, S is sample standard deviation, and N is sample size. And then we can compare this T calculated with T tabulated to interpret the result. But as I said earlier, the SPSS software or any software generates the p-value. So there is no need to compare the calculated value with the tabulated value. We compare the level of significance with p-value to interpret the result. Let's take some examples. Suppose the average weight of the newborn baby in India is 2,800 grams. Right, so here this 2,800 grams is a population mean. Now to check this statement, we need to collect the data from the population randomly, and then we compare the sample weight of the collected data with this population mean. Now how do you frame the null hypothesis in this case? So our null hypothesis is the average weight of the newborn baby in India is not significantly different from 2,800 grams. An alternative hypothesis is the average weight of the newborn baby is significantly different from 2,800 grams. So this is how we can frame the null and alternative hypothesis. Let's take second example. The average monthly salary in clothing industry in Bangladesh is $1,000. So again, the population mean is given, that is $1,000, right? Now here we can frame the null hypothesis as the average monthly salary in clothing industry in Bangladesh is not significantly different from $1,000. And the alternative hypothesis is the average monthly salary in clothing industry in Bangladesh is $1,000, is significantly different from $1,000. So let me take some questions. The first question is how to check the normality. There are various ways to check the normality. You can use the graphical method. You can use the statistical tests, but statistical tests are more robust than the graphical method. You can check our video on the normality test. There are two statistical tests, Shapiro-Wilk test and Kolmogorov-Smirnov test, to find the normality assumption, to find whether our sample is normally distributed or not. Second question is observed mean. Is it sample mean? Yes, observed mean and sample mean are same. If population mean we do not know, then how will perform one sample t-test? One sample t-test is not, you cannot use one sample t-test if population mean is unknown, because one sample t-test is used to compare the population mean and sample mean. So population mean is known to the researcher, is known to the person who is performing this test. Yeah, if you have any other doubts, you can write in the comment. So let's go to the SPSS file and I will show you how to perform the one test in SPSS. So this is my variable view. The first variable is ID. I have generated ID, so it's a nominal variable. Second is gender. This is also a nominal variable. So here I have given the values. 1 is given to male and 2 is given to female. Right? This is the part of the data entry. You can also find the video on how to enter the data, how to define the variable, how to enter the data in SPSS, how to give values to the nominal variable on our YouTube channel. So kindly go through it. So here I have given I have assigned code 1 to male and code 2 to female, and here order doesn't matter. That is why this variable is nominal. Income is a quantitative variable, so here I'm going to select scale. Expenditure is also a quantitative variable, so I'm going to select scale. So this is my data view. I have 20 observations. You can see here. Income of the 20 observations or 20 respondents, and this column shows the expenditure of these 20 respondents. This shows the gender. So here you can change the view if you want to change by using this icon, value labels. So if I click on value labels, it shows me the name of the label that we have assigned to that code, and here you can see the code, that is 1212. So you can adjust as per your convenience. Now, how to perform this one sample t-test? Now, what I want to know? Suppose my question is, or I want to know whether this sample is collected from the population having income of $20,000. Suppose this is in $1,000. So here I am writing in labels income in $1,000 per month, and expenditure is also in $1,000 per month. So I want to know whether this sample is collected from the population with having $17,000 income per month. So my population mean is $17,000. That is 70. So to perform one sample t-test, go to analyze, compare means, one sample t-test. I'm repeating myself. Go to analyze, compare means, one sample t-test. So once you click on one sample t-test, this dialog box will appear on your screen. Now, what is our test variable? We want to compare the income of this sample with a given population mean. So it is income. Sorry, go to variable view and write income in $1,000. So I'm writing income, and here I'm writing expenditure. Okay, so again go to analyze, compare means, one sample t-test. My test variable is income, so I'm selecting income. So once you select the income, the variable income will come in this test variable box. So what is our test value? The test value is our given population mean. So the given population mean is 17. We are interested in to know whether this sample is collected from the population having $17,000 income per month. So simply click OK and go to your output window. So this is the output of t-test. The first table shows the descriptive statistics. So if you see n is 20, so the sample size is 20. Mean, that is sample mean, x bar. If you remember the formula, x bar minus mu. So here the x bar is 16. Standard deviation is 4.10 and standard error is 0.918. See this table, one sample t-test. The test value is 17. This shows that we are comparing the test value. We are comparing the sample with this test value 17. So here t statistic is minus 1.090. Degree of freedom is 19, that is n minus 1. What is sample size 20? 20 minus 1 is 19. This SIG value, two-tailed, is our p value. So to interpret the result, we are going to compare this value with our level of significance, that is alpha. Mean difference is minus 1. What is mean difference? The difference between population mean and sample mean. So what is our population mean? That is 17. What is our sample mean? 16. So 16 minus 17 is minus 1. So here this SIG value is 0.289. By default, the alpha is 0.05. So here this SIG value is higher than 0.05. Since this value is higher than 0.05, we fail to reject the null hypothesis. Now, what is the null hypothesis in this case? The null hypothesis is the sample mean is not significantly different from $17,000 income per month. And we fail to reject that null hypothesis. So what we are going to conclude? We say that this sample is taken from the population having $17,000 income per month. So this is how we can interpret this result. So now I'm taking some questions. If you have any doubts, you can write in the comment. So I guess why test value mean is 17 is chosen? Is it randomly selected? Yet assume that it is given. Suppose I'll show you if the sample, if the population mean is 20. So when you collect the data, the population mean is already known to you. So here I have selected 17 because it is known to me. I assume that it is known to me, right? Repeat the interpretation, sure. This table, the first table shows the sample statistics, that is n, sample size 20. Mean is 16. This is population mean. Standard deviation is 4.10 and standard error, that is 0.918. Now see the second table, that is one sample test. T statistic. What is the formula? X bar minus mu upon S under root n. So that is minus 1.090. Degree of freedom is 19. That is 20 minus 1, n minus 1. SIG value is 0.289. Now we are going to compare this value with our significance, level of significance. So what is our level of significance? It is 0.05. Now this SIG value is higher than 0.05. And therefore we fail to reject the null hypothesis. In this example, the null hypothesis is the data or the sample is collected from the population having a mean income salary of 17,000, or the sample mean is not significantly different from the population mean, that is 17,000. We fail to reject the null hypothesis, and therefore we conclude that this sample is taken from the population having mean income of $17,000 per month. I hope it is clear now. So let's take another value and see what happens. So I'm again going to the one sample t-test box. Instead of this 17, I'm going to write 25. The test value is 25. So what is our null hypothesis in this case? The null hypothesis is this sample is taken from the population of mean income salary of $25,000 per month. So simply click OK, and you can see the outcome or the result in the output window. So the first table remains the same because it is about the sample. Sample size is 20, mean is 16, standard deviation is 4.10, and standard error is 0.918. See here, T statistic is minus 9.80. Degree of freedom is 19. You see the mean difference, it is minus 9. That is 16 minus 25. That is our test value. Right? Now, if we compare this SIG value, that is 0.000, this is less than 0.05. Since it is less than 0.05, we reject the null hypothesis. So what is null hypothesis in this case? The sample mean is not significantly different from the population mean, that is $25,000, income of $25,000 per month. And we are going to reject that null hypothesis. So we conclude that this sample is not taken from the population having the mean income salary of $25,000. So this is how you can perform the one sample t-test and interpret the result. Now let's understand the second type of t-test, that is paired t-test. What is paired t-test? A paired t-test is used to compare two means which are from the same observation, that is before after comparison, or from the paired data or related groups. So if you want to compare the before after, or we want to compare the effectiveness of any event. So before event, what was the position, and after event, what is going to happen to the observation, that is before after comparison, or when we have the paired data or two groups are related with each other. In that case, we are going to use the paired t-test. So observation from sample 1, one observation from sample 1 is uniquely associated with only one observation in sample 2. And therefore, two samples are correlated with each other. So here the observation of sample 1 is uniquely associated with the observation of sample 2. So that association makes a pair. So in paired data, we do not analyze their means separately. We are not going to analyze the mean of two samples separately. We rather analyze the difference in their means. Whether that difference in the means is statistically significant or not. So here we are not going to compare we are not going to treat these two samples separately. We rather we rather compare the mean. We compare these two samples, and then we are going to analyze the difference between these the mean difference between these two paired groups, these two related groups. So what is the null hypothesis in this case? So null hypothesis is there is no significance difference between the means of two paired groups. Here we say that there is no significant difference between the means of two paired groups, or the means of two paired groups are equal. We can also write that the sample mean of the first group is not significantly different from the second group. Alternative hypothesis is there is a significant difference between the means of two paired groups, or the means of two paired groups are not equal. So this is how we can frame the null and alternative hypothesis in case of paired t-test. This is the formula to calculate the t statistic. Here d bar is the mean of the difference. D bar is mean of the difference, S is the sample standard deviation, and N is the sample size. Now, since the observation of first sample is uniquely associated with the observation of the second sample, the sample size in both the samples are same. Let's understand it with the help of example. We want to know whether open book examination improves the result of the students or not. This is an experiment, and we want to check whether this open book examination helps the students to improve the result or not. So for this, exam is conducted in regular atmosphere, which is known as controlled condition. The condition is controlled in that case. And for one set of students. And for the second set of students, the open book examination is conducted, and that is known as experimental condition. So here, the one student from the first set, that is controlled condition, is uniquely associated with the second set of student, which is the experimental group. And in this case, students are identical. This is very important. So students are identical in other qualitative parameters like same class, same level, same background, etc., etc. So therefore, a student from control group makes a pair with one student in experimental group, and then we discuss or then we analyze whether the result of these two groups are different, are statistically different or not. Let's understand another example. Suppose we are interested in knowing the difference between the opinion of husband and wife on whether children should be sent to English medium school or vernacular medium school. So again, a husband and wife makes a pair. They can't be treated as independent samples. They are correlated with each other. And therefore, independent sample status cannot be used. We have to use the paired t-test. So I'm taking some questions now. The question is why we are writing 25 instead of 25,000. Yeah, we are writing 25 because I have written the data. Let me show you. This is my. So here we have written in $1,000 already. We are writing in the variable. If you see this label, income $1,000 per month, and I have written here uh, in this manner. So if you write here 15,000, you must write 25,000 in the test value. Another question is same observation in different, same observation pre and post in same group. Yes, we can use the effect of a training program on the productivity of the employee. So we are collecting the data from the same observation before the productivity, before the training program and after the training program. So we are collecting the data from the same observation at two different points of time, before some event and after some event. In that case also we can use the paired t-test. Different between paired sample t-test and independent sample t-test. Yeah, that this the difference between these two will be covered when we discuss the independent sample t-test. Okay, so I have this file with me. The variable first is ID, that is nominal variable. Second is gender. So again, I have assigned 1 to male and 2 to female. You can see on your screen. So this is also a nominal variable. So I'm selecting nominal in measure. Marks 1, that shows the marks before remedial classes. You can see here. Marks before remedial classes. And marks 2 shows the marks after remedial classes. So both are quantitative variable. I'm selecting scale in the measures. Okay, so this is our data. First variable is ID. Second is gender. 1 is assigned to male, 2 is assigned to female. Marks 1 shows the marks before remedial classes out of 100. And marks 2 shows the marks after remedial classes out of 100. So what we are going to examine, I want to know the effect of remedial classes on the result of the students, right? So this is my data. We have 15 observations. Let me increase the size. Okay. So we have 15 students. I have collected the data from the 15 students. Marks 1 shows the marks of the students before remedial classes. And marks 2 shows the marks of the students after remedial classes. Now, what is the null hypothesis in this case? The null hypothesis is there is no significant effect of remedial classes on the marks of the students, or the mean marks before remedial classes is not significantly different from the marks after remedial classes. They both are equal. What is the alternative hypothesis? The alternative hypothesis is marks before remedial classes is significantly different from the marks after remedial classes, or the remedial classes have a significant effect on the result of the students. So this is our null and alternative hypothesis in this case, in this example. So here again, I'm repeating myself. We have 4 variables: ID, gender, marks 1 and marks 2. To perform a paired t-test, go to analyze, compare means, paired samples t-test. Again, go to analyze, compare means, paired samples t-test. So once you click on paired samples t-test, this dialog box will appear on your screen. So what is our paired variable? our first variable is marks before remedial classes, and second variable is marks after remedial classes. So our variable 1 is marks 1 and variable 2 is marks 2. If you click on options, the confidence interval percentage is by default 95%, which means that our level of significance, that is alpha, is 0.05. We can change the level of significance to 99% or 90%. But here I am continuing with this confidence interval percentage. So simply click on continue and click on OK. Now go to your output window. So this is the output of paired data. First table shows the sample statistics. Mean marks of students before remedial classes is 65.40. You can see here. After remedial classes, the mean marks is 69.40. Data, that is sample size, is 1515. This is standard deviation and standard error. See here this correlation table, which shows that these two variables, these two groups are correlated with each other, and this correlation is significant because this value is less than 0.05. Right? Now see this table, paired samples t-test. The difference, mean difference is -4. You can see here 65.40 minus 69.40. See the first table. The mean difference between two groups is -4. T statistic here -1.961. T statistic. Degree of freedom is 14. That is n-1. 15 minus 1, which is equal to 14. And SIG value, that is P value, is 0.07. Now, what is our level of significance? It is 0.05. Now, this value is higher than 0.05. So, we fail to reject the null hypothesis. Now, what is null hypothesis? Remedial classes do not have any significant effect on the result of the students. And we are going to fail to reject the null hypothesis. So, we conclude that the marks before remedial classes is statistically significantly not different from the marks after remedial classes. So in other words, we can say that remedial classes do not have any significant impact on the result of the students. So this is how we can compare the these two paired groups and the interpretation of the result. So I'm taking some questions. Difference between, okay, in example 2, why it is a paired data? Because husband and wife cannot be treated as an independent sample. They are correlated with each other. Suppose you are taking the data from the twins, that is also a paired data. Brother and sister, father and daughter, mother and son, or mother and daughter, father and son. These are paired data. These are the examples of the paired data because they are correlated with each other. What happens if samples are different in both groups, or they should be equal? In paired samples, the observation of sample 1 is uniquely associated with the observation of sample 2. So the sample size in both the samples must be same. Because if the sample size are different, you cannot find the association with these two samples. What differentiates Wilcoxon sign rank test and paired t-test? The Wilcoxon sign rank test is used when the data is non-normal. That's a non-parametric test. You can see our video on non-parametric test. All non-parametric tests are there to compare the means. So when our data is not normally distributed, we are going to use the non-parametric test. So Wilcoxon signed rank test is a non-parametric test and the data is either nominal or interval or so. So here you cannot use, the t-test cannot be used if the data is nominal or ordinal. But you can use the non-parametric test even if your data is nominal or ordinal. Next question is, what differentiate Wilcoxon? Okay, I have answered that. Sample mean and population mean difference is n minus 1. No, sample mean and population mean means the value of the sample mean minus the value of the population mean. If you remember the formula of the one sample t-test, it is x bar minus mu. So x bar is your sample mean minus mu, that is your population mean. That is the difference between sample and population mean. Okay, so going back to the theory of independent t-test. So the first test is one sample t-test, which can be used to compare the sample mean with population mean. Paired t-test, which is used to compare the mean difference of two related groups. But suppose we have two independent or unpaired groups. Two independent or unpaired groups. Then we are going to use the independent samples t-test to compare the means. So here two samples are taken from two unrelated populations and then we compare the means between these two groups. So it is also referred to as two samples t-test because two samples are not related with each other. They are independent of each other. So here the observations in one group cannot make a pair with the observation of another group. Right, in paired t-test we can say that the observation of first sample can uniquely make a pair with the observation of the second sample. But here the observation in one group cannot make a pair with the observation of the second group. And that is why two samples are independent of each other. They are unrelated. They are unpaired. So what is the null hypothesis? Here the null hypothesis is there is no significant difference between the means of two unrelated groups, or the means of two unrelated groups are equal. H1, that is alternative hypothesis. There is a significant difference between the means of two unrelated groups, which means that the two unrelated groups, the mean of one group or one sample is significantly different from the mean of other sample or other group, or the means of two unrelated groups are not equal. So this is the null and alternative hypothesis of independent samples t-test. This is the formula to calculate the sample statistic. X1 bar is the sample mean of first sample or first group. Sample mean of first group. X2 bar sample mean of second group, and one size of group 1, and 2 shows the size of group 2, and S is the sample standard deviation. So with the help of this formula, we can calculate the t statistic manually. But software generates these results, so there is no need to calculate it manually. Let's take some examples. Suppose we want to know whether people live in urban area and rural area have a different opinion about sending their children to English or vernacular language school. Recall the example that we have taken in the paired t-test. We have taken the example of opinion of husband and wife that can make a pair. But here we are collecting the data from urban area and rural area. So the observation, the respondent of an urban area cannot make a pair with the respondent of the rural area. So these two groups are totally independent of each other, and therefore independent t-test can be used. Right, so I've written that we have two unrelated populations or groups, and hence paired t-test cannot be employed to test the mean difference. Suppose we want to know the spending pattern of people working in corporate and government sector. So in this case, one sample is collected from the people working in the corporate sector, and the second sample is collected from the people working in the government sector. So again, people working in the corporate sector does not make a pair with people working in the corporate sector, government sector, and therefore we cannot use the paired t-test. Now, what is the null hypothesis in this case? Suppose we are interested in knowing the spending pattern of people, whether there is any significant difference in the expenditure or income of government sector and corporate sector employees. So we can say that there is no significant difference in the expenditure of government and corporate employees, against the alternative hypothesis of a significant difference in the consumption expenditure of the government and corporate sector employee. So let's understand the SPSS. Yes, so this is our data. Again, we have these four variables: income, gender, income, and expenditure. ID, gender, income, expenditure. Shows the income of the respondents in $1,000 per month. Expenditure is also measured in $1,000 per month. This is our data. I have 20 observations. You can see on your screen the observations. This column shows the gender of the observation or the respondent. This shows the income, and this shows the expenditure. Now I want to know whether the income of male and female is significantly different or not. Right? I've collected this data, and I want to know whether the consumption, whether the income of the employees of a particular company, suppose I've collected this data from a particular company. So whether the income of male and female is significantly different or not. So here we have two unrelated groups, male and female, because observation from male group cannot make a pair with the observation of the female group. So what is the null hypothesis in this example? The null hypothesis is the income of male is not significantly different from the income of female, right? Or income of male and female is equal. So to perform this independent samples t-test, go to analyze, compare means. Here we have the option of independent samples t-test. Again, go to analyze, compare means, independent samples t-test. So once you click on independent samples t-test, the dialog box will appear on your screen. Now, what is our test variable? Our test variable is income, because we want to compare the income of male and female. So select this income variable, click on this arrow. So that variable will come in this test variable box. Now here we need to define the groups. So grouping variable is gender. So select gender, click on this. You can see these two question marks in this box. So now we need to tell the SPSS that which codes we have assigned to the groups. So click on define group. So group 1 is 1 because we have assigned 1 to male, and group 2 is female. So suppose we assign 0 and 1, so you can write here 0 and 1. Suppose you have assigned 4 and 5, you can write 4 and 5. But we need to tell the SPSS that we have assigned 1 to group 1, that is male, and 2 to group 2, that is female. So click on continue. Go to options. Again, here we have confidence interval percentage 95%. So our level of significance is 0.05. You can change as per your requirement, but that I am continuing with this default confidence interval percentage, that is 95%. So click on continue. Simply click on OK and see your output window. The first table is the sample statistics. You can see the sample size. So here sample size is different. See, N, there are 11 males and 9 females. So in independent sample t-test, we can have the different sample size because the observation of first sample does not make a pair with the observation of the second sample. The mean income salary, is 17.91 and mean income salary of female is 13.67. You can see the standard deviation and standard error of mean. Now, here we have this Levin's test for equality of variances. Here, if you see, we have two T statistics. T statistic for equal variances assumed and equal variances are not assumed. So whether the variances of two groups are equal or not, that can be explained with the help of Levin's test for equality of variances. Now the null hypothesis of the Levin's test is the variance of group 1 is not significantly different from the variance of the second group. So if you see the SIG value, the P value is higher than 0.05. See on your screen, the Levin's test for equality of variances. SIG value is 0.882, which is higher than 0.05. So we fail to reject the null hypothesis. What is null hypothesis? Variances are not significantly different from each other. So we conclude that the variance of sample 1 is not significantly different from sample 2. So variances are equal. And therefore, we use this t-test, which is associated with the equal variances assumed. So here sample statistic is 2.635, which is calculated with that formula x1 bar minus x2 bar upon s under root 1 upon n plus n1 plus 1 upon n2. Degree of freedom is 18. That is n1 plus n2 minus 2. So here you see n1 is 11, n2 is 9, that is 20 minus 2, which is equal to 18. The SIG value is 0.17. Mean difference is 4.242. That is the mean difference between male and female, the income of male and female. So if you see the difference here, 17.91 minus 13.67, which is equal to 4.242. Now SIG value is 0.017. Since this value is less than 0.05, we reject the null hypothesis. What is null hypothesis? The mean income salary of male is not significantly different from female. We are going to reject that null hypothesis, and therefore we conclude that the mean income salary of male is significantly different from the mean income salary of female. So there is a significant difference between the income of the male and female in this example. So this is the interpretation of the independent samples t-test. Let me give some questions. If want to check knowledge score before intervention and post intervention only in one group, which test should be used? If want to check knowledge score before intervention and post intervention. So if your data is normally distributed, you can use the paired t-test. And if it is not normally distributed, you can go for non-parametric test like Wilcoxon sign rank test. Is there any standard ratio between questions and response received? I am not getting your question, Anju ma'am. Is there, which to take equal variance is assumed or not assumed? Will you tell please again? Yeah, sure. See here, you have Levin's test for equality of variances. So we use this Levin's test. Now, what is the null hypothesis of Levin's test? The null hypothesis is there is no significant difference in the variances of two samples. So if you see the SIG value 0.882, Now 0.882 is higher than 0.05. So therefore, we fail to reject the null hypothesis. Now, what is the null hypothesis in 11 states? There is no significant difference. So we can conclude that variances are equal, and therefore we can go for equal variances assumed. I hope it is clear. Another question is Mann-Whitney test, compare means of two independent samples. Yeah, Mann-Whitney test is again used when data is not normally distributed. So Mann-Whitney test is a non-parametric test. An independent sample t-test is a parametric test. So if your data is normally distributed, use the parametric tests like one sample, paired t-test, independent t-test. And if your data is not normally distributed, go for non-parametric test like Mann-Whitney U-test, Kruskal-Wallis test, or Wilcoxon-Sign rank test. You can find the video on the non-parametric test on our YouTube channel. What if Levin's test is significant? If Levin's test is significant, use the second value, that is equal variance is not assumed. We have the value of t statistic for both the cases. So if equal variance is assumed, go for the first case, first value. If it is not equal, if they are not equal, go for the second value. So I think you are now able to use the SPSS for this test. Again, if you want to do the practice, you can find the difference between male and female expenditure also. So whether the consumption expenditure of male is significantly different from the consumption expenditure of the female, right? So we are ending this session now. If you have any doubts in future, you can write in the comment. I request you all to subscribe to our YouTube channel, Crack Economics and Statistics. Thank you for joining this session and kindly help us to build the network across the globe. The quiz link will be sent to you today or day after or tomorrow to for the e-certificate. So kindly fill the quiz and submit it on time. So you will receive your e-certificate on your email ID. Thank you for joining us. And again, do not forget to subscribe to our YouTube channel. Thank you, everyone.